Hello everyone. Today I am going to discuss the third problem of AtCoder beginner contest 359, which is tile distance 2. So the problem is quite hard to me. Like we have to make some observations and I got stuck in the problem. So let's discuss the problem idea first. What is the problem? Let's say this is a grid. Okay, this is kind of a grid structure. So uh, two cells. Let's say this is one cell. So two cells are merged in this way. You don't have to read the this problem formal problem statement. You can just look at the diagram. You will understand it better. That in the first, let's say if uh, I is the zeroth, like the even number of row, it is even. Let's say this is 0 comma 0, then if this is a even number of row, then these two rows are merged, and if it is odd number of row, then these two rows are merged. Okay, so let me copy this image uh, and paste it here. Okay, so what I am trying to say is that uh, so let's say this is 0 comma 0, right? This is 0 comma 0, 0 comma 0. So these two cells are merged. The column 0 and column 1 are merged if the row number is even, and if the row number is odd, because this is the zeroth row and then this will be the first row, then the column number 1 and 2 is merged like that. Now we will be given some source row column and destination row column, some source row column and the destination row column. Let's say we are in this index and you have to find the number of moves to reach this index. Okay, so we can move from one cell to another cell. So we have to find the minimum number of moves to move from the source cell or to the destination cell, or source box to the destination box, you can say. So if it is if the cells are not merged into a square, into a rectangle of 2 cross 1, then it is a easy problem. We have to find the Manhattan distance between 2 points. But here the cells are merged into uh, these two cells are merged into one rectangle of 2 cross 1. Okay, so how we can solve this problem? So the first observation we have to make, another thing is that the constants on sx and sy, tx and ty are 2 into 10 to the power 16. So order of n type of solution is not accepted. You have to solve somehow in log n or in some constant time solution. Okay, so the first observation I made is that let's say at one jump, like we are jumping from the one tile to another tile, the row number is modified by 1. Row number is modified by 1. But let's say this is the first observation. This is the first observation. Second observation is that let's say we are moving in the same row. Let's say we are moving in the same row. Then at each jump we are jumping by 2 indexes. So let's say we are at 0. Then after the next jump will be moved to the second column, and after the next jump we'll be moving to the fourth column like that. Okay, so that's why if we are moving in the same row, then the column will be jumped from 0 to 2 to 4 like that. Okay, now these are the two main observations. So our answer will be obviously the lower limit of answer will obviously be our ty minus sy. Okay, ty minus sy, this is the lower limit of the answer, so the answer should be greater than this. Okay, now one brute force way to solve this is that we'll brute force way, not brute force way, one greedy way you can say, that we'll be jumping from this row to this row. Let's say we are jumping from first row to this row diagonally, then second row to third row diagonally, and after we reach the destination row, we'll this way jump this way. Okay, so here you can see that when we are, let's say we are at this index, and we are making one jump, diagonal jump, then we are moving to the first column. After we are moving, let me mark here. Let's say we are at this point. Okay, let's say we are at this point and we are making some diagonal jump, then we'll be getting to the this point. Okay, we'll be getting to this point, and after the next jump we'll be getting to the this point. Okay, so here you can see the when the row number is increasing by 1, in the diagonal jump the column number is increasing by 1. Okay, when the row number is increasing by 1, the column number is increasing by 1. So let's say these are the number of jumps will be required from to get from the source row to the destination row. So let's call this P. So in the P jumps we'll be getting, let's say we are at source X column, so we'll be getting to the source X plus P number column. Okay, so after that the destination column will be Tx. So this thing, we have to go Sx plus P to Tx. We have to go this in, we can jump by 2. If we are moving in the same row we can jump by 2. So we have to take Tx minus Sx plus P. We have to take this entire thing by 2. Okay, and we have to add P here. That is the answer, but there is a catch here. There is a catch here. I am saying that we are at some point. Okay, we are at some point, but we are not exactly at some point. Here you can see that we are at Tx plus 0.5 to Ty plus 0.5. So what we have to do, let's say we are at something like this at this point. Let's say we are at this point, then we have to find the leftmost corner of this tile. We have to find the leftmost corner of this tile. Okay, so for this, let's say we are present at this position, then our point will be this one. And let's say we are present and at this position, then our uh, point will be this one. So we have to find the our row position, let's say our cell position from the given position sx comma sy. Let's say we are given something sx comma sy, and we have to find our the point position. Let's call that px comma py. So how can we do that? That is one important thing. Let's say for that one ad hoc handling will be required. That let's say we are at let's say we are at some even row. Let's say we are at some even row. Let's say we are at this row. This is even row. Then uh, our sx value, let's say sx value is 1. Okay, sx value is 1, and we are at even row. Then our point value will be 0, right? Our point value will be 0. Now let's say we are at some odd row, let's say 5. So we are at some odd row, let's say 5. Then our point value, sorry, let me take some other example. Let me clear this thing. Okay, you'll understand it better. Let me copy this thing again. Mm, let's say this is the uh, let's say we are at this position, right? Let's say we are at this position. Then our point value will be this, our cell index. So we are at 0th row and 1 column. This is 1. Then our position will be nothing but 0 comma 0. But let's say we are at 1 2 3 let's say we are at 0 1 2. Let's say we are at this position. Let's say we are at 2 comma 1. Okay, let's say we are at 2 comma 1. Then our point value will be nothing but this position, right? This position is nothing but uh, 1 comma 1. So one thing to observe here is that parity if the parity of the uh, sx, if the parity of the row and the parity of the column is not matching, then we are only decrementing the value of the row, decrementing the value of the column. If the parity is matching, we are not changing that. You can make some trial and error, like you can take something like 5 comma 6 and try to find what cell this position belongs to. Okay, I hope you get that. Now let's jump onto the code. Here sx and s from the sx and sy, from sx comma sy, we are changing the value of the current position to the uh, tile position, you can say. Okay, that's why if the parity of sy and sx are not matching, the row and column parity are not matching, we are decrementing the value of sx by 1. Similar thing we are doing for finding the correct column for the destination tile. Okay, and this part is straightforward. We are doing p equals to absolute value of ty minus sy, and q is the absolute value of tx minus sx. Now if p is greater than equals to q, that means the number of columns we are jumping, are greater, number of rows we are jumping are greater than the number of columns. Then we are printing just the number of columns we have to jump. Otherwise we are printing p, the number of diagonal jumps, and after the diagonal jumps are over, we are doing q minus p by 2. Okay, I hope you get it. if you have any doubt in any part of the explanation or code, you can ask me in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thank you.